Hey guys, this is Mr. Grice for Algebra 2 Unit 4.10 Notes, Day 1. Today we're going to be talking about characteristics of quadratic functions. Our learning target today is to be able to identify the solutions, rate of change, and domain of range of quadratic functions. Now, this is a review, as people are so excited in the hallway and yelling. They're excited too. It's just a review. So today should be pretty easy. Nothing terrible. Now, a solution of a quadratic equation, those are the x values at which the parabola intersects the x-axis, okay? When it's intersecting, okay, that's when it crosses, okay? So what we need to do is find the solutions of the function below, and there are three possible solutions. So what you need to do is find the x-axis, okay? And boom, those are my two solutions. So my first point is -2. So I'm going to use a different pen real quick. That's -2, 0. And then right here, that is the point 0, 0. So what my answers are -2 and 0 because those are the x values. Okay, so we could have two solutions. Let's look at the next one. Once again, it's saying find the number of solutions. So I'm looking at my x-axis, finding the point. Oh, how many times does this one? Yeah, this one is just one. So this one is the one solution. So once again, I'm looking at the point. That's the point 1, 0. So we would say that x equals 1. Yeah, and that's all. Good job. Hopefully somebody's saying, hey, that's the vertex. That's also the line of axis of symmetry. On that parabola, it is. And you are correct. All right. And then number 3, find the solution. So once again, we're looking for the x-axis in this one. Where does it cross? Does it ever cross the x-axis? No, so we would say that this is no real solution, okay? When it's no real solution, this is where we get into the imaginary numbers, okay? But we would just say that it's no real solution. All right, come on, Mr. Grice, that was Unit 1 stuff. Okay, next thing we're talking about is the average rate of change between two specific points of a function. That is their slope. So I want to know, what is the slope or the average rate of change between 2 points? Guess what? This is Unit 1 stuff too. So what it's asking us to do, finding the average rate of change between these 2 points, but all they did was tell me, yeah, all they told me was x values. Okay, so when f is -1, so when I have this -1, boom, there's my point. My point is right here. And then when f is 1, I go to 1, boom. I'm going to use the other blue. I like that one better. Okay, so what is my average rate of change? How do I get from one point to the other? Well, in this case, between these points, I had to go down 4 and to the right 2. Okay? So if my slope is -4/2, what does that equal? Yeah, that equals -2. So we would say that our average rate of change is -2. We always want to reduce, yes, always reduce that number. Okay, find the average rate of change between 2 and 3. Okay, so I've got my first point, which is 2, my second point, which is 3. I gotta find my answer. So 2. Here's 2. I go down and I find my point. Then it tells me to go to 3. So I'm at 3. Boom. I find my point. Now, how many up do I go? Well, I went 1, 2, 3, 4, 5, 6. I went up 6 and over 1. So 6 over 1 is the same thing as 6. So 6 is my final answer. Now, without a graph, uh-oh, I have to find the average rate of change for the function of h of x. So I have our function right here. H of x equals 1/2 x minus 4x plus 12, and I have 2 points. Remember, these are our x values, okay? We could say that this is x1 and this is x2. Those are the 2 numbers that I want to plug in. So I would plug it in twice. I have h of 6 equals 1/2 x squared minus 4 times x plus 12. So when I plug in 6, what do I get? Well, use your calculator, guys. Okay. I have 1/2, so I have 1/2 times 6 squared minus, 4 times 6 plus 12. And what'd you get? Yeah, 6. So we got h of 6, which equals 6, and that is the point 6 comma 6. So now I'm going to do the exact same thing, except the second time I do this, I'm going to plug in 8. Sorry, don't forget it's 8 squared. Okay. So h of 8, when I plug that in, what'd you get? I'll just let you guys do it. Yeah, when you plug that in, you should get 12, and so that is the point 8 comma 12. So here's my deal. I need to find the slope, and I have 2 points. So if I have 2 points, that means to find my slope or my average rate of change, that I have to do y2 minus y1 over x2 minus x1. So our final part is we're using those numbers, and I'm doing my y's, so 12 minus 6, and then 8 minus 6. 12 minus 6 is 6, 8 minus 6 is 2, and then 6 divided by 2, we get 3. So our final answer is 3. Okay? Yes, that one's probably the hardest part to do because it's a little bit more work. There's no graph, so you have to figure it out yourself. All right, last part. Domain and range. Okay, so domain is how far left to right we go. Okay, domain is always your x-axis. And then our range is our high and our low. That is our y-axis. Okay, so if we're finding the domain and range, domain is how far left. So how far left does it go and how far right does it go? Is there anything stopping that? No. Okay, so our domain, that goes from negative infinity to positive infinity. Okay, because it goes all the way to the left and all the way to the right. It just keeps going and going. Now, the next thing we need to talk about is our range. Now, my range does not go on forever and ever and ever, because if you look at it, I can't be down here at all. There's a specific stopping point or starting point. We start here at -2. -2 is where I start, but then it goes up and 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 up forever and ever and ever and ever and ever. So my range, I'm starting at -2, but then it goes on to positive infinity. Do you guys remember that? All right, so number 6, we're doing the same thing. We need to find what is our domain and what is our range. Okay? So domain is our x value, that's our left to right. And if you don't see any specific starts and stops, that means, because even though it's going down, it's going to go down and it's going to go wide in both directions. So my domain is negative infinity to positive infinity. And then my range is different this time because you can see that I go all the way down. I start all the way down here, which is at negative infinity, but I come up here and I stop. That's as high as I go, and I stop at 3. So this time I'm starting at negative infinity, but then I have a specific stop point, which is as high as I can go at 3. Okay? So hopefully, guys, this is a lot of review. Your homework is a lot of the same stuff. Okay, 4.10 practice on the other side. If you have any questions, please come see Ms. Carranza or myself. We would love to help you out. Otherwise, this is Mr. Grice signing off for Algebra 2, Unit 4.10 Notes, Day 1. Thanks for watching.